Hello, am I audible to you? Hello?
Yes, sir.
Yeah, okay. So, good morning to all of you. Today we will start or rather we will continue our previous lecture that we have completed for mesh analysis and loop analysis. Loop analysis or mesh analysis and nodal analysis. So, as you can see here, we have completed this mesh method or loop method, which is also called as mesh current method. And in the previous example, we have taken to demonstrate this mesh method and loop node method, we have taken another example. So this example is also very similar to the previous one, that is in this you can see here three loops are there, and in all three to identify the loop currents. Okay, and so in mesh method or loop method, we have to identify the number of meshes, and then we have to make the direction of current flowing through the meshes. And the direction, for simplicity, we will take direction that is clockwise. Okay, that you already know. And we have to denote the current values in different loops. So as you can see here, there are three loops. So three currents are denoted, I1, I2, and I3 respective to the loops. Okay. Then we have to apply KVL in this mesh method. So in each and every loop we have to apply KVL, and then we have to find out the loop current KVL equations, number of KVL equations based on the number of meshes. Okay, meshes or loops. So we have to find out here in this problem, we have to find out three number of equations, KVL equations based on the three loops. Okay, loop 1, loop 2, loop 3. So you can see that to apply KVL, the elements are there and sources are there. Okay, so in every branch you can see some sources will be there and some elements will be there. For simplicity, we have taken here resistive load, a resistive element. So only resistors are there in this circuit. Okay. Summarize next, that is nodal method. In nodal method or node voltage analysis, we have to identify the number of nodes in a circuit. Okay, number of nodes we have to identify, and one node we have to assume as a reference node where potential will be zero or where ground will be connected. So generally, I told in the previous class also, generally in the bottom side you will take the reference node, bottom side node of the circuit, or the basic fundamental is the reference node is the node where from where maximum number of branches are connected. So but in some cases, in some nodes, you can also see in the circuit that in some nodes the number of branches connected are same, just like you can see that this node and this node. So in these two nodes, the number of branches connected are same. At this node 1, 2, and 3 branches are connected. At this node 2 also you can see 1, 2, and 3 nodes are connected. Okay, so to simplify the problem and to identify or to write the KCL equations in this node method in a simpler way, we have to take the reference node as a bottom side of this circuit. Okay, so one node will be as a reference node. Remaining nodes are 3 in the circuit. So there are total 4 nodes in the circuit. One node we have assumed as a reference node. So remaining 3 nodes, at remaining 3 nodes we have to apply KCL. Okay, and we have to write KCL equations, and by writing the current direction here, some current direction, you can see that in all branches current direction is denoted. Okay, so based on the current direction you have to assume as per your own. Based on the current direction you have to write KCL equations. Okay, and the idea is to write to assume node voltages at each noded. Okay, nodes. So you can see that this is node 1. So node voltage V1 you can assume. At node 2, node voltage V2 you can assume. At node 3, node voltage V3 you can assume. So you can see that here the equation at node 1 is written in terms of V1, V2 and V3. Okay, this is V1, V2, V3. So all incoming and outgoing currents you have to take, and you know that as per the KCL, the algebraic sum of all incoming and outgoing currents will be 0. So based on that you have to write KCL equations at each and every node. Okay, except from this reference node. Okay, so this is the basic procedure of node method and mesh method. Now there are some special circuits where you cannot apply simple node method or mesh method. Okay, so what is the problem? If you will apply, if you want to apply mesh method, so you can see that if voltage, because you have to apply KVL in the loops. So if only voltage sources are there is no issue. If there is current source available in the circuit, hello, somebody want to say anything? Okay, so if there is current source available in the circuit, how you will solve using mesh method? Suppose if there is current source here, in place of this resistor, if there is current source, so how will you apply KVL if there is a current source here?
उसके क्रॉस कोई वोल्टेज ले लेंगे और दोनों लूप में अपोजिट डायरेक्शन में केवीएल लगा करके सॉल्व करेंगे तो वहाँ का जो वोल्टेज आएगा वो तो कट ही जाएगा ना, कैंसिल हो जाएगा।
नहीं वो ठीक है, लेकिन वो वोल्टेज एज्यूम करेंगे, वो वोल्टेज भी तो अननोन रहेगा ना।
करंट सोर्स जो रहेगा तो करंट सोर्स के मतलब अननोन रहेगा तो बाद में अगर कट जा रहा है तो उसका तो कोई मतलब बचेगा नहीं।
कटेगा कैसे?
अगर आप जैसे करंट रेशियो के अकॉर्डिंग अगर आप किसी भी इस पोलरिटी में वोल्टेज लेते हैं तो वो दो जो आपका लूप है, लूप 1 और लूप 2, उसमें अगर आप अपोजिट डायरेक्शन में अगर मतलब दो ही क्वेश्चन निकल के आ जाएगा ना आपका, अगर लगाइएगा केवीएल तो आप उसमें उसको हटा तो सकते हैं ना, लेकिन
ठीक है, आप ट्राई करना एक बार।
मैं एक मिनट, एक क्वेश्चन आप दिए हुए थे उसमें ट्राई किए थे तो वो बन गया था वैसे।
कौन सा क्वेश्चन था?
कल जो आप डाले हुए थे असाइनमेंट का उसका लास्ट क्वेश्चन।
हाँ हाँ हाँ, okay, we will see, but I will tell you another method, that is a special case of mesh analysis and node analysis, super mesh and super node. Okay, so regarding this I am talking. Okay, so just see this example. Firstly, we will cover this super node method. So if you want to apply node method, simple node method, okay? If you want to apply simple node method, so in this problem, how many nodes are there? How many nodes are there?
4 nodes.
3. 1, 2, and this one. This is a common node, right? So it is a reference node also, where maximum number of branches are connected. You can see that first, second, third, fourth. 4 branches are connected together with this node. Okay. Here you can see that the node voltages at this point will be 0 because this is grounded. So remaining we have 2 nodes only. This is node 1 and node 2. Okay. So node voltage V1 and V2 is represented. So how we'll apply simple node method? If you want to apply node method, how you can solve? You have to assume the currents. Okay. As per our procedure, we have to assume current. Suppose I have taken I1 here, I2 here. In any direction we can assume current. Here I3 and here also some current will be there. So suppose this is I4, right? If you want to apply simple node method, as per the node method, you have to write 2 KCL equations at node 1 and node 2. Clear? So KCL at node 1. There are 2 incoming currents, 2 plus I1, and 2 outgoing currents are there, I2 plus I4. Right? What is I1? How we can write the value of I1 in terms of V1, node voltage V1?
I2 plus I4.
No, I am talking
V1 minus 0 by 2.
how we can write the value of I1 in terms of V1?
So V minus V1 upon 2.
0 minus V1 upon 2.
V1 minus 0 upon 2.
V1 minus 0 कैसे होगा?
If
V1 minus V1 by 2.
If current is in the upward direction, okay, this is element. You know that in element current will flow from higher potential to lower potential, right?
Yeah, yes, sir.
This is higher potential, this is lower potential. So polarity will be voltage drop will be plus here, minus here across this element, right?
V1 by 2.
Clear? So if you have assumed the node voltage V1 at node 1, node voltage V1, by default we have assumed this is plus, okay, and the another terminal is connected to the ground. Okay, so it means what will be the value of I1? Voltage polarity is plus here, here minus, here plus, then minus. Okay, so it means this is the voltage at this terminal is 0. So this I1 will be equal to 0 minus V1 by 2. Okay. 0 minus V1 by 2. Clear?
Yes, sir.
Yes.
The current direction is downward, then it will be V1 minus 0 by 2.
Yes, sir.
Then what is the value of I2? The polarity will be plus here, minus here, as this is an element. So you know that as per the rule, the current will flow.
V1 minus V2 by 2.
V1 minus V2 by 2.
V1 minus V2 by 2.
V1 minus V2 by 2, right? Then I4, what is the value of I4?
So by 10.
Sir, by 10
10
आएगा.
होगा ना.
Yes. The resistance value is 10, so it will be 10. What is the value of I4?
So 0 minus V2 upon 4. Sir, V2 minus 0 upon 4.
V2 minus 0 upon 4.
V2 minus V1.
Value of I4.
No, sir, upon 2.
I4 will be
V2 minus V1 upon.
V2 minus V1 upon what?
सर उसमें तो ऐसा लिखेंगे ना कि I1 जा रहा है 2 एम्पियर जा रहा है तो I1 plus 2 minus I2 equals to I4 आ जाएगा क्योंकि रेजिस्टेंस तो है नहीं तो डायरेक्ट कैसे होगा.
Yes. There is no element here. Okay, there is no element. Only voltage source is there in between V1 and V2. So we cannot identify the value of current based on this voltage upon resistance. You know that the current is V by Z. Z is any impedance. So here in resistive network, we have taken resistance value. So it will be V by R. So it means in the denominator, resistance must be there. In between V1 and V2, only voltage source is there. There is no resistance. So I4, you don't know. You have to write in terms of this. I4 is equal to 2 plus I1 minus I2. Right? So I4 is unknown here. Okay. Then KCL at node 2. If you will apply KCL at node 2, so what will be the equation? How many?
I2 plus I4 equals to I3 plus 7.
Yes, I2 plus I4 is equal to I3 plus 7. Two incoming currents, I2 and I4, two outgoing current, I3 and 7. So I2 we can directly write it here, V1 minus V2 by 10 plus I4, that is equal to I3 is equal to
V2 by 4.
I3 is equal to V2 minus 0 by 4 plus 7. Okay. Here also V2 is unknown. I4 is unknown. Okay. So you can see that there are two equations. As per the node, applying KCL at the nodes, we got two equations where we have three variables, V1, V2, I4. V1, V2, I4. So anyhow, we have to find out the value of I4. Okay. So it means if we want to solve by using simple mesh method, this problem, So we have to solve many equations. Okay, we have to tackle many equations. There is a simpler way to solve these circuits, these type of circuits where in between two nodes is if there is a voltage source connected. And if you want to apply mesh method, node method, so by using super node, you can solve very easily. By using super node, you can solve very easily. So we will see what is super node. Okay. Clear? So we will take this problem again and we will apply super node. Okay. So we have seen in the previous method, if we want to solve this method using only node method, simple node method, so we have to solve, apart from two equations, we have to solve many some more equations also to get the value of I4. Okay, so there is a simpler way that is called super node method, where we will assume this V1, V2 and 2 volt together a node. It is called super node. Okay. So in super node, if there is any circuit where in between two nodes if there is voltage source connected, use super node method to solve easily. Okay, so we will apply super node, and as per the super node we have to take all together V1, V2 and 2 volt together as a super node. So it means if we have assumed this as a super node, so we have to apply KCL at this node only. This is a node. So at this node, there are many branches connected. This one, this one, this one, this one, and this 10 ohm also. So we have assumed current, just we can see in the previous I1, we have assumed I2, I4, I3. So we will assume I1, I2, same current, I3 we have assumed. Okay. So at super node we have to assume a voltage also. So we will take voltage value at super node. So by applying KCL at supernode, इस सुपरनोड पे कितने इनकमिंग करेंट्स हैं? हाउ मेनी इनकमिंग करेंट्स आर देयर?
1.
1.
2. 2 plus I1. Both are incoming currents, right?
Yes, sir.
How many outgoing currents are there?
I3 plus 7.
And what about I2?
और वो तो लेफ्ट से आके उसी में मिल गया ना, राइट.
Hmm?
I2, I3 and 7 ampere.
I2, I3 and 7 ampere. So so 2 plus I1 is equal to I3 plus 7. What about I2? I2 is just like if you will see, if this is a node and the situation is like this. This is super node. Node voltage you have assumed V. 10 ohm is connected. This is I2. So it is a loop itself. Okay. So the incoming currents, here it is outgoing, here it is incoming. So we cannot assume this current. This will be a loop. Okay. And that's why we will take I3 and 7 only for KCL. So what will be the value of I1? Same it will be there. I1 we have assumed in the previous while applying simple node method. 0 minus, now it will be 0 minus V divided by 2, right?
सर
Yeah.
सर अगर ऐसा कोई करंट है जो उसी लूप में है तो उसको इनकमिंग भी नहीं काउंट करेंगे और आउटगोइंग भी काउंट नहीं करेंगे, मतलब जैसे I2 है तो वो कुछ भी नहीं है.
I2
सर
हम्म
सर अगर सुपर नोड का वोल्टेज अपन ने V मान लिया है तो फिर 10 ओम तो शॉर्ट कर जाएगा ना, क्योंकि उसके बीच में पोटेंशियल ड्रॉप ही नहीं आ रहा है, तो I2 की वैल्यू 0.
हाँ ये भी है, सेम वोल्टेज है, सेम
तो
वोल्टेज है.
10 ओम
I2 की वैल्यू इसके अकॉर्डिंग 0 होगी.
10 ओम शॉर्ट कर
Okay.
जाएगा.
If we have applied super node, so here the same voltage is there. So I2 का value, because here voltage is V,
ओके सर समझ गए. V1 is equal to V2 है.
I2 will be 0 as per this super node. If we have assumed as a super node, so I2 will be 0. What
ओके
is
सर.
the value of I3? I3 will be same V minus 0 by 4, right? Plus 7. So we can directly find out the value of V here from equation, from this equation. Four minus V is equal to V plus 28. No. By 2 is equal by 4. Okay. 4 minus v divided by 2 is equal to v plus 28 divided by 4. So it will be 8 minus 2v, that will be v plus 28. So 3v is equal to 8 minus 28. V is equal to minus 20 by 3. V is equal to minus 20 by 3. Okay. So this is equation number 1. Now we have to take one KVL also in this super node method. Okay. Whether it is for super node or super mesh, you have to use both KVL and KCL, because we have assumed the value of V here, but we don't know the value of V1 and V2. So what will be the value of V1 and V2, that we will identify. So what will be the value of V?
V1 plus
If we have assumed the current direction I4 here, so V will be equal to, what will be the value of V? This is higher potential, this is lower potential. If we have assumed the current direction here, okay, by assuming this as an element, this is V1 minus V2, V1 minus V2 together with this 2 volt will be the value of V. So it means value of V will be equal to V1 plus 2 minus V2. That will be V. Okay. Is it clear to all of you? V1 plus 2 minus V2 is equal to V. This is V1, and if we have assumed the current direction in this direction, so V1 minus V2, and if we'll apply KVL from here to here, so V1 plus 2V and minus V2 is equal to V. So here will be V1 plus 2 minus V2 is equal to V, and V is minus 20 by 3. So minus 20 by 3.
Sir, what does negative sign implies here?
Which negative sign? This voltage value.
Sir,
This voltage value implies that the terminal voltage will be reversed. Okay. Previously, if we have taken plus minus, if the polarity of voltage we have assumed plus here minus here, so it will be reversed. Okay. Means here it will be plus, here it will be minus. Just the polarity will reverse. Okay. So V1 minus V2 plus 2 is equal to minus 20 by 3, means plus 20 by 3 is equal to 0. So 3V1 minus 3V2 plus 26 is equal to 0. Okay. So we have to calculate the values of I1, I2, I3, I4. Okay. So V1 minus V2 we have identified, that is V1 minus V2 is equal to minus 26 by 3, or we can write V2 minus V1 is equal to 26 by 3. So if you will apply KVL in this loop, yeah, one more thing is that you know that V1 minus V2, this I2 is equal to I2 is equal to V1 minus V2 by 10. So if we find out the value of I2, I2 is equal to V1 minus V2 by 10. So what will be the value of I2? V1 minus V2 is equal to minus 26 by 3. Minus 26 by 3 divided by 10. That is minus 2.6 by 3 ampere. That will be the value of I2. And
सर सर डायग्राम से अपन देख के ये नहीं बोल सकते कि V1 और V2 के बीच में 2 वोल्ट का डिफरेंस वोल्टेज मेंटेन है,
हाँ बोल
क्योंकि तो यहाँ से अगर V1 माइनस V2 या फिर V2 माइनस V1 देखे तो डायग्राम से 2 वोल्ट आना चाहिए। अपन ने वहां पे 26/3 फाइंड आउट किया है, कॉन्ट्राडिक्ट नहीं हो गया?
I4 भी तो है सर वहाँ।
ये बात तो सही है। V1 माइनस
डायग्राम से तो 2 वोल्ट मेंटेन होना चाहिए, बट अपन ने 26/3 निकाला है तो
yes 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 okay because this voltage value we have assumed as a यहाँ पे KVL अप्लाई करने में प्रॉब्लम।
सर सर हम लोग निकालना क्या चाह रहे थे यहाँ पे, अभी अभी ज्वाइन किया है।
We want to calculate the value of branch currents.
Okay sir.
Okay, so here the KVL we have applied, that is wrong. Okay, so we will apply KVL again. So when we will apply KVL, we can see that V1 plus 2 minus V2 is equal to 0. KVL equation will be V1 plus 2 minus V2 is equal to 0. So it means V1 minus V2 is equal to minus 2. This is our equation number 2. Okay. Okay. So we have V is equal to minus 20 by 3. V1 minus V2 is equal to minus 2. So what will be the value of I1? I1 we have to identify because we don't have the value of V1. Okay, in terms of V1 and V2 means there is a difference between V1 and V2. So please think how we can calculate the value of V1 and V2 separately.
सर ये
0
वाली
minus
इक्वेशन
V1 upon 2.
Hmm?
0 minus V1 upon 2 is the value of I1.
Yeah, but we don't know the value of V1 right now. V1 is also unknown.
Sir, 10 by 18 in opposite direction that you have taken.
10 by
18.
10 by what?
18, sir. 1 8.
18. How we can identify the value of V1 10 by 18?
सर मैंने केसीएल लगाया था सर, ऊपर से मैंने मान लिया 1/5 एम्पियर का करंट आ रहा है V1 में,
Hmm.
और सर नीचे से I1 और 2 है, तो वहां पे मैंने केसीएल लगा दिया था इक्वेशन बना के, तो उससे मेरी वैल्यू आ रही है.
Okay. Any other?
सर
सर
यहाँ
V1
V1 माइनस V2 2 बोल रहे हैं, तो I4 का यहाँ पे कोई यूज नहीं होगा.
I4 का यूज नहीं, I4 कैलकुलेट करने के लिए हमको I1, I2 और I3 फाइंड आउट करना पड़ेगा पहले. Then
नहीं,
we can identify the value of I4 by using KCL.
no sir, like by diagram we are saying that V1 minus V2 should be 2 volts.
हाँ, yes.
Then if there would be I4, then it would be something else, na? Like how it could be 2 volt if some current is going through that.
No. In between V1 and V2, only this voltage source is there.
There would be no drop for this I4.
No, drop will be there, obviously. Okay, I4, we have to calculate the value of I4, but I4 will be equal to 2 plus I1 minus I2. Okay,
Yes sir.
sum of these two currents minus I2 will be I4. So we have to identify first the value of I1 and I2. Then only we can find the value of I4.
सर V2 माइनस V1 जो है वो 2 के बराबर होगा, 2 वोल्ट के बराबर.
V2 minus V1 is equal to 2, yes.
और सर V1 माइनस 0/2 हो जाएगा I1, और V2 माइनस 0 हो जाएगा 4/4 हो जाएगा I3.
Wait, 1, 2, 3, 4, 5.
सर
Yes. Wait.
ओके सर.
Okay, so
सर फिर हमारे पास 2 वेरिएबल और 2 इक्वेशंस बचेंगी तो सॉल्व हो जाएगा।
नो नो, इसमें केवल 2 ही इक्वेशन से सॉल्व हो जाएगा।
हाँ
जब सुपर नोड हम लगाएंगे, सुपर नोड में हमको केसीएल अप्लाई करने में प्रॉब्लम हुआ है शायद। ठीक है, सुपर नोड में केसीएल अप्लाई करने में प्रॉब्लम हुआ है, और यहाँ पे जो वोल्टेज हम एज्यूम किए हैं वी, ये हमको एज्यूम करने की ज़रूरत नहीं है, क्योंकि ऑलरेडी V1 और V2 यहाँ पे नोड पे दिया हुआ है।
यस सर यस।
तो इसको एक डमी नोड मान के हमको केसीएल अप्लाई करना है। ठीक है, सो डमी नोड मान के केसीएल अप्लाई करना है। 1 2 3 4 हो गया। So by applying KCL, इस V की जगह पे हम जो V1 और V2 है वही रखेंगे। ओके, माइनस V1, दिस विल बी V2, V2 माइनस 0/4। सो इट विल कम इन टर्म्स ऑफ V1 एंड V2। मिस्टेक यहाँ हुआ है, because the equation must come in terms of V1 and V2, then only we can solve the value of V1 V2. So this will be 8 minus 2V1 is equal to V2 plus 28. So minus 2V1 minus V2 is equal to 20. This is equation number 1. Next equation we have just written here, V1 minus V2 is equal to minus 2. So we have two equations.
सर ये 8 minus 2V1 कहाँ से आया?
This is okay. If I will further simplify, it will be 4 minus V1 by 2.
अच्छा, okay, so you solved the first
Yeah,
equation.
V2 plus 28 by 4. Okay, so we have to multiply by 2 also, so that denominator we can cancel.
Okay, sorry.
Minus 2V1 is equal to V2 plus 28. So minus 2V1 minus V2 is equal to 20, equation number 1. Here we have written equation by applying KVL in this super node. So V1 plus 2 minus V2 is equal to 0. It means V1 minus V2 is equal to minus 2. So now we have two equations and two variables V1 and V2. Okay, so we can easily get the value of V1 and V2. Minus 2V1 minus V2 is equal to 20. V1 minus V2 is equal to minus 2. By subtracting these two equations, we can easily get the value of V1 and V2. V2 will be cancelled out. Minus 3V1 is equal to 22. So V1 is equal to minus 22 by 3. So V2 we can identify by putting the value of V1 in any one equation. V2 will be equal to V1 plus 2. V1 plus 2. So minus 22 by 3 plus 2. That will be 6, 14 minus 16 by 3. Right? Minus 16 by 3 volt. Minus 22 by 3 volt. Okay. So V1 we have calculated minus 22 by 3, minus 22 by 3, V2 minus 16 by 3. So what will be the value of I1?
Eleven by 3.
I1 we have seen that 0 minus V1 by 2. So minus V1 by 2. So it means 22 by 3 divided by 2. That is 11 by 3 ampere, right? So the direction of I1 is correct. That we have assumed. Means we are getting positive value of I1. It means the direction whatever we have assumed that is correct. Okay. Value of I2 will be V1 minus V2 by 10. V1 minus V2 by 10.
0.2.
Minus 22 by 3. And V2 is minus 16 by 3. So plus 16 by 3 divided by 10. So it will come negative. 6 by 3, that is 2. So minus 2 by 10, minus 0.2, minus 0.2 ampere, right? Correct? So the direction what we have assumed for I2, that is not correct. So it means I2 direction actually will be in this way. Clear? Because we are getting negative value of I2, so that's why the actual direction of current I2 will be in this way. Now, what is the value of I3? I3 will be equal to V2 by 4, right? V2 is minus 16 by 3 divided by 4. It means minus 4 by 3 ampere. It means the direction of I3 is also wrong. What we have taken means I3 direction will be from in the direction of in upward direction. The actual direction of I3 will be in upward direction. Clear? Then if you want to calculate the value of I4, what will be the value of I4? I4 will be equal to 2 plus I1 minus I2. So I4 will be equal to 2 plus I1. I1 is 11 by 3 minus I2. I2 is 0.2 plus 0.2. Means the direction of I4 is correct. So whatever we have assumed for the direction of current I4, that is correct. So this much ampere will flow through this branch, voltage source. Okay. Clear to all of you?
Sir, could you please show the last page?
Last page,
Yes, sir, this one.
this one. So yeah, attendance. आशीष चंद्रा.
सर कल एक बार ये क्वेश्चन थोड़ा ब्रीफली फिर से एक्सप्लेन कर देंगे?
यस बिल्कुल.
ओके,
कोई और
थैंक यू.
एग्जांपल भी देख लेंगे.
थैंक
आशीष चंद्रा, आव्या चंद्रा,
प्रेजेंट सर.
आदित्य आरएस,
प्रेजेंट सर.
आकाश श्रीवास्तव,
Present, sir.
अखिलेश साहू,
प्रेजेंट सर.
अक्षित तनेजा,
प्रेजेंट सर.
आनंद कुमावत,
प्रेजेंट सर।
अंकित दास,
प्रेजेंट सर।
अपूर्व राज, अर्णव
प्रेजेंट सर।
कुमार, अर्णव कुमार, अविनाश कुमार सिंह,
प्रेजेंट सर।
आयुष कुमार सिंह,
प्रेजेंट सर।
गौरव तिवारी,
प्रेजेंट सर।
ईशान सिंह,
यस सर।
कृष्णा गुप्ता,
प्रेजेंट सर।
मैत्री उपल,
प्रेजेंट सर।
मुद्रा गुप्ता,
प्रेजेंट सर।
रंजय सोनी,
प्रेजेंट सर।
प्राची गौतम,
प्रेजेंट सर।
प्रज्वल सिंह,
प्रेजेंट सर।
प्रियांश राज,
यस सर।
प्रियांशु कुमार,
प्रेजेंट सर।
पुलकित सिंह, राहुल, राजीव कुमार पांडे, ऋषभ आर्या,
प्रेजेंट सर।
ऋषभ,
यस सर।
ओके, रोहन कुंतल, एस ऋतिक साई,
प्रेजेंट सर।
साकेत सुमन, सम्यक कश्यप, संग्राम चक्रवर्ती,
प्रेजेंट सर।
शशांक त्रिपाठी,
प्रेजेंट सर।
शुभम रंजन,
प्रेजेंट सर।
शुभम सिंह,
प्रेजेंट सर।
सृजन स्वरांकर,
प्रेजेंट सर।
सुधांशु कुमार,
प्रेजेंट सर।
सुजीत कुमार, सुमित सिकरवार, सुप्रिया,
प्रेजेंट सर।
सूर्यांश वर्मा,
प्रेजेंट सर।
उज्जवल नयन,
प्रेजेंट सर।
उत्कर्ष,
प्रेजेंट सर।
वैष्णवी,
प्रेजेंट सर।
वेदांशी,
प्रेजेंट सर।
विशाल वेस्ले,
प्रेजेंट सर।
यश यश बावस्कर, अर्णव कुमार, विनीता भाटिया,
सर
प्रेजेंट
यश
सर।
बावस्कर इज प्रेजेंट।
ओके ओके,
प्रेजेंट सर।
संभवी श्रीवास्तव, शशि शेखर मिश्रा,
प्रेजेंट सर। शांभवी श्रीवास्तव प्रेजेंट।
ओके ओके, शशि शेखर मिश्रा, एनी अदर?
यस सर मी
व्हाट इज योर नेम?
स्वास्तिक मिश्रा।
Swastik Mishra, you have late joined.
यस सर।
Swastik Mishra. Okay.
I am also present. यशवर्धन चौहान।
यशवर्धन चौहान, okay, then you can join your next class.
सर गूगल क्लासरूम का लिंक मिल सकता है? हम लोगों ने अभी भी ज्वाइन किया था, हमारे पास लिंक नहीं है इसका।
लिंक आपको मिल जाएगा।
ओके सर, थैंक यू सर।
Okay, thank you.